I guess I have two passions. I guess one is deer hunting and the other one is water and wells. And I think they both started about the same time. I guess I grew up on a farm, and one year my dad decided when I was about 13, 14, he needed to have the garden was getting dry, so somebody's got to drive a sand point in there and get extra water for the garden. Well, of course, when you're that age, you're pretty gullible, so he calls a neighbor over and he goes and he starts witching, and wouldn't you know it, he puts it right in the middle of the brush and weeds and whatever, mosquitoes, and says, that's where the water is. Well, me and my brother, probably 3 days later, I don't think we ever did get it to go, but basically we dug down and we put the sand point on and we pounded on that thing like there's no tomorrow. Well, after you get a little wiser and down the road when you really figure out what geology is, I could have went any place. I could have put it right by the garden and not sat in that mosquito and wood tick infested woods putting that thing in, but sometimes you learn things and you're just naive about stuff. But I've been doing this for 30 years. Mark, my partner, and myself took the business over from his dad in 1982. We basically started out just doing irrigation and residential work, got into the municipal work, and I guess I always told him, when I get bored, I'm going to be gone and you'll have to find new partners. 30 years I'm still here, so I guess I must have found that little hole in the ground interesting. Sometimes things aren't as what you think. I guess I just came back from Belize a week ago, and my wife hates traveling with me because whenever I go there, being in water, I got to find out where their water's coming from and where it's going and all that stuff. Of course, I find out the septic tank's running over in the front yard, and it's like, okay, I wonder where the water's coming from. Well, interesting, I have a friend down there, and he connected me up with a gal from Ontario who was down with the United Nations working on some initiative for these third world countries. So I got to tag along with her and go to some of these rural water installations where they're pumping water from. So, kind of get off task of vacation, driving my wife up the wall, but I sure had a good time, so. But anyway, I've been hunting this here same buck for 2 years, and somebody up front asked him if he's hanging on the wall yet. No, I haven't figured out his strategy yet because I've never found him on a daytime picture. But I figured one day he's going to screw up and come out during the day, but so far he's been winning. With that, I'll move on to the topic at hand here. If I figure out the controls. You got the wrong right. This is a generic picture of a rig of a well. This one happens to be, I think, Rogers, Minnesota, before they developed everything down there. A little bit of quick background. I won't spend a lot of time on the numbers and math and things like that because I think nobody's in any mood to write numbers down and remember formulas and stuff like that. But if you just remember where you can find the answer, I think that's the important thing today is, oh yeah, I remember something about that, and go from there. Just a little bit of information. You may have seen these pie charts around. I see different ones around and the percentages vary. Of course, it depends on the year, where the source is or whatever, but basically 70% of the water in Minnesota is served by community water systems of some sort. This chart again, irrigation, they're shown at 26%. 2 years ago, that number was probably more approaching the yellow slice because I think irrigation in a really drought year will probably be rivaling the usage of municipal water systems. So if any of you have been involved with the DNR and getting permits and whatever, there's kind of a new push on water appropriations, and I think that's going to be a whole ongoing thing. We have to identify how much we have for resources and how much can we use responsibly, and I always keep coming back to the same thing. Just got put on the task force for down in Bonanza Valley with the DNR, trying to help come up with some regulations down there. But I think the thing that going forward we have to think about the 3 R's: recycle, reuse, and recharge. Because as long as it keeps raining, we'll have water, but we have to figure out how to keep it where we got it. It's going to change our strategy and how we deal with water and what we do with it. I'll first go into the troubleshooting and resolving well problems. Again, there's going to be some numbers and some information in there. Don't expect you to write it down or remember it because I know you're not that bored. The importance of record keeping. If I get a call from a customer and they identify that something's not working right, of course I'm going to come up with a list of questions. It's kind of like going to the doctors and you don't communicate to him what the symptoms are, he's probably going to have a difficult time coming up with some sort of diagnosis for whatever might be wrong. So that's where record keeping is important. And one of the most critical pieces that I look for is, okay, I always break it up. When you walk in the pump house, you look at it as a well, and I look at it as two different things. I look at, okay, I've got a well, and I've got a pump. One won't work well without the other. They got to be working together. So you're looking at pump performance on one side, that's a mechanical thing. Then you're looking at the well side, and one will affect the other, but they're two distinct different problems, usually. Some people say when your pump's out, call trouble. Okay, but what if you want to do some diagnostics yourself? Great. If you can get on the phone with me or somebody who can walk you through it, but you need to know some information. If you just tell them my pump is pumping slower and it's running longer, probably going to be doing, we're going to talk, but we're not going to communicate and get down to the bottom of the problem. We need to have some hard facts. Just recently had a city explain to me for the last year, I have one well with my water static level continuing to decline. Well, that's all fine. It's got instruments and the latest and greatest of everything in there. Well, when I look at the well log, look at the pumping data, I mean, the facts just didn't support it. So I said, well, before we start spending money on here, let's go back the old-fashioned way. Let's go pull out the instrument, go with the old hand drawdown gauge there and confirm what's going on. Well, good thing to say, it was just a bad instrument that was trending down and it was giving them a year worth of bad data. So sometimes you gotta look back and say, okay, what's going on? But back again, if they didn't have previous records, we wouldn't know where to start. So records are going to be helpful, and then you should also have what's called an as-built drawing, because a lot of times if I can't figure out what's going on, if somebody can send me, fax me, email me an as-built drawing, I at least know what's going on. It kind of drives my pump crews crazy once in a while, but if you do it for 30 years, it's kind of like my brother. He's at the Model Ts, and you show him a Model T engine, he'll look at the serial number and he'll tell you if that one was built in Canada or was built in the US, or whatever. It's like, I don't want to go that far to old antique cars, but that's his passion. On pumps, if I look at an as-built, a lot of times, even if there's no numbers on it, I can identify what it is. I guess that's what you get when you do it long enough. Identifying what you have, and you need to figure out what you have for pumps, controls, and the well. Here's a real typical as-built for a line shaft turbine. It's good to have some information. Upper left-hand corner would be the well information. Sometimes it's nice to know the engineering firms because they may have some records on file that they forgot to forward to you guys when the project was completed. When you're looking for drawings, that's when you need it, right? On the right-hand side would basically be the pump information right up on the right, and then of course in the middle is just a quick snapshot of depth of the well, depth of the pump. And me, for one, I look at some of these old records, and believe it or not, I've worked with some cities where they'll pull out pieces of paper. I didn't know paper lasted that long, but it would be like 1897 or 1900, but the paper's pretty, like an old Bible, it's pretty crumply, but everything's written out in hand form. So apparently they didn't draw stickmen and granimals like I did when I was in school, because I can't draw more than a stickman. But basically, you got to read everything and then wrap your head around what the language is of what they're saying and whatever. And usually they'll say something like, you know, Peter and Jimmy went down to the local hardware store to get some more bolts because we broke some bolts, or they had to go get a piece of wood for a timber for the drilling rig. So some interesting information, but again, usually no drawings, but if you can get a drawing, this really helps out. So this would be a pretty common one for a line shaft turbine. We do one for every well and pump we put in, because even if I'm not working on it, you pull up one piece of paper and with a couple minutes you look at it and you can tell what's going on. This is another one, but this would be for a submersible for with a pitless installation. If your well's located outside the pump house, you're going to have the pitless adapter right there, but basically same fields of information, well data on the left, pump on the right, and all the quick and easy stuff that you can identify on the right. This is another one with a submersible, but that would be a typical in the pump house type installation. Usually we'll start out, and again, I'm going to go through these kind of fast. I realize it's early in the morning, but I guess we just got to remember where to find the answer. Usually you'll come up with a situation. This is one where the motor does not start. You walk in, everything's dead. Okay, we got a troubleshooting chart. Obviously, there's going to be things like check the power, check the fuses, check your pressure switch or your telemetry. Maybe there's a delay that went bad or something like that, because I know a lot of these have a little delayed start. So that's pretty much all in the electrical controls section. So that's usually the first thing you look for if something just doesn't start and get up and off dead center. Here's a situation where the pump starts too frequently. Well, I would assume there's probably a few towers this winter way up north, and I was on one on the funnest day of this winter that I can remember. It was minus 37 when my truck was pointing south in the sun. It was a sunshiny day and it still said minus 37. It was no fun, but I think the tower was about 80% ice because we sure didn't get very much water pump before our pressure range started changing, so there must have been a little circle about that big up there that wasn't froze. So, but anyway, could be a pressure tank, could be any number of things. You could have a check valve. I was at one not too long ago where everything's real quiet in the pump house, and here we can see about 30 gallons a minute running back down the well that they almost never use. So I don't know how long it was running down that well, but I would assume for a couple of years. Well, 30 gallons a minute, and you do the math, it's a lot of water that they were sending back down the well that they hardly ever use. It was their backup well. But again, it was a backup well. The only reason they knew it is they froze the pump house up because the heater quit, and I came out there and started looking for other things, and I said, well, you got more problems here. And said, that noise isn't right. And he goes, well, it always does that noise. So he looked, and sure enough, the water's running down the well, and it's been doing it for as long as he can remember. So I guess the point of that is just because it always was that way doesn't make it right. Another one, motor runs continuously or won't stop. You could have a leak in the system. Most commonly, you'll have a worn out pump. It just can't achieve the pressure that it once did. You could have a broken shaft. The well could be breaking suction. There's a number of things, but again, this is just a checklist to go through. Here's one, motor runs, but the overload protectors will kick out or be a problem. So if it runs, everything seems to work, but it wants to stop, kick out the overload. Well, then there's a list we'll go through. You could have bad controls, bad cable, worn pump, short to ground. There's a number of things on that one there again. So here's the chart we use. Again, don't remember the numbers, but when we have a submersible that's down 200 or 300 feet, we'll take an instrument, we send 1,000 volts down into the motor, and we can measure the amount of electrical leakage to ground. That's called an insulation test. So we can usually tell, the nice thing about this test is, and I do it for some customers on a yearly basis, we'll go and do an insulation test, and you can actually watch a motor mature as it gets older. The insulation values from year to year will start decreasing, or your leakage to ground will increase, because insulation, as it gets, I guess I'll use the word wore out, kind of sounds bad for insulation, but what happens is from the heating and cooling process, eventually insulation in the motor will start deteriorating and you'll start going to ground. Used to be, with old controls, the motor would just run until the smoke came out of the control box, and then the motor would be burnt like a piece of toast when you pull it out. For those of you who have VFDs, if the VFD is set up properly, usually the VFD will give you an earth fault indication way before the motor will fail, which some people go in and disable the earth fault problem, or in the drive, so they fix the problem, at least electronically. But the problem is, you just took out the safety fuse, which is identifying a ground. So usually, if you bypass that feature, the next time it fails, it'll smoke the motor and the drive. So you got to be a little bit careful if you're going to start disabling some of your safety features that are in the VFD. Here's your pretty basic one. I'll start with that first. Top is just a regular old single breaker there with the motor starter there and the overload on the bottom. Pretty straightforward, pretty vanilla. That's what you see in a lot of small pump houses or pressure tanks. Been around for many, many years. Then they started coming up with smarter controls, same as what above, but then they add extra apparatus in there so it can start identifying when you have a problem. In other words, they're starting to put smartness into the cabinet and saying, okay, well, if it starts overloading, what's my problem? And it'll give you some sort of information on that. Different schematics on them, and there's no way we're going to go through explaining the schematics today, but that's basically how they lay out. Franklin Electric came out with a thing a number of years ago called a sub-monitor. I'm not a big fan of them, and the reason I'm not a big fan of them is they have great ideas and great features, and basically it's supposed to do what a VFD does, is basically accept that I have a problem with that in some situations. It will do a fine job with overload protection if the power company gives you over voltage on a continuous basis, under voltage on a continuous basis. But if you have power spikes, it usually won't catch it because it has a sampler in there, and every so often it goes out and catches a sample. I guess my analogy of that is, if I'm out taking pictures in a storm, just because I can't click the shutter quick enough doesn't mean that it didn't actually lightning. If I hear the thunder, I know it lightning somewhere. Same thing with this thing here. If a spike comes in and it only samples once every minute, I may have totally missed my electrical spike coming in. And we see a lot of submersible motors fail because of a power spike and the monitor didn't catch it. VFDs are on fractions of a second, so they do a really good job of catching power spikes or power abnormalities coming in. This is the same product, just they're basically just showing the LED readout with giving you the faults and what they can find and whatever. So it has its purpose, but I'm not a big fan of them because I think they give you a false sense of security. If you really want to get something and you have power issues, you probably want to consider a drive. Here's a VFD installation in a pump house. By code, you don't need to have a NEMA 3R box. I typically recommend a NEMA 3R box because, let's face it, you're working in a pump house. There's water in a pump house. Sooner or later, there's going to be a leak somewhere. And when it does, if it sprays to the electrical panel and wipes out your VFD, you've got thousands of dollars that it's going to be going up in smoke, because VFDs don't like water at all. So this box here is, next picture I show, it's got heaters in it, it's got a cooling fan in it, it's double insulated, so basically you can spray a garden hose at it all day long and it won't be an issue. The other reason I put this picture in here is one of the biggest failures we see out there with VFDs on submersible motors is people are misapplying them or misprogramming them. They are very specific on how they have to be programmed on a submersible motor. It's not like a regular motor. The other thing is, down in the lower corner here, the VFD is up here. There's three, looks like little transformer coils right in here. It's called a DV/DT filter. And what happens is, on a VFD, the longer the lead is, it's kind of like a crack of the whip. The sinusoidal wave of three-phase power gets more distorted. So the motor insulation is only good for 1200 volts, which is 3 times rated. So if you come in at 460 volts, 3 times 460, you're going to be pushing past that. This, without a DV/DT in here, you will actually, if you ever put an oscilloscope on it, you can actually see the spikes of about 1600 plus volts. It all depends on the length of the line. And what will happen is, over a period of time, it's kind of like if any of you have been in shop class and the shop teacher turns off the lights and you lift the car hood up and you look underneath the spark plug wires and you see the sparks jumping around underneath there. That's what you got going on inside the motor. I've actually seen, I have a city I put a brand new motor in for. It was less than 500 hours on the motor, and they kept complaining about noise. Pulled the motor out, it's like, you know, there's something's not right here. Everything's brand spanking new. Everything, the pump house, the electrical, the service, everything. Turns out that within 500 hours, them spikes of electricity, you could take the race off of the bearing, and it looked like a corrugated culvert in there. It had, they call it fluting, it had rings in there, and we ended up having to put different equipment in there to basically harness the transient electricity, but basically that's what happens. You'll have some serious problems if you don't put one of them in on a submersible pump. And you may have to put them in on some above ground pumps, but that's site specific and it's hard to nail that down. Anyway, I'm going to move next into wells, but I just wanted to cover the pump section first, and certainly be rude and raise your hand and throw a question if you have one, because by the time the end of the session comes, we might run out of time or forget what we wanted to ask, so go ahead.
What's your opinion on that VFD being outside of the pump house? With the heater in it?
The question is what do I think about putting VFDs outside? Have lots of them outside. What I have learned is they'll work 30 below zero, but what happens is, and the box that I showed you does have a built-in heater. It's not insulated, but it does have a built-in heater, kind of like putting about a 100-watt bulb in there. It keeps it warm enough. What we have happen though, if I back up here, right behind the door there, the LED screen, if you ever work on any electrical equipment, the actual LED screen, the readout, it'll still function and do everything on the back. It'll still start, it'll still run, but your screen may be slow or may not even come illuminated at all if the screen is too cold. And usually that happens right around 0, 10 below zero, nothing happens. It's just black or nothing happens. But the drive will still run. If they're properly protected inside of a NEMA 3R enclosure or whatever, got lots of them outside, working fine.
Well, we've got one too, but I just wondered what,
Yep.
and we had the exact situation that you explained, a water leak, a heater stuck on,
Okay.
and there was plastic lines in there for the shower head.
Okay.
It actually melted that,
Okay.
and of course, it smoked the VFD and all of.
So you had one of them little brass heater apparatuses in there, like screwed to like a light bulb socket type thing, or?
No, not the VFD,
Okay.
but our electric heater for the pump.
Okay, gotcha.
Thermostat stuck on, and we go in there in the morning to check, and of course, the steam's coming out of there. And it's like, oh my God, and the first thing it did was wreck that VFD. Well, the solution was to put it outside away from the chemicals and everything else, and it's got a heater in it. It's been working fine for 5 years.
Yeah. One thing I've noticed with drives, and I guess I was working on a site one time where literally I saw a drop of water come off of the guy took the lid off the drive, luckily it wasn't mine, and there was summertime, condensating pipes up above it, and it went drip. I was just standing right behind him, one drop of water came down, and just like you threw a firecracker off, out came the smoke and it was all done. One drop of water. So they don't like water very good. That's why I really like to see them in a NEMA 3R enclosure. I think it's safety. Yes?
Follow-up question here on his outside VFD drives.
Yep.
Typically when it's been getting so cold this year, we get an under temp fault. What's that telling you when it says under temp?
When you get faults on the drive, the thing you have to try and key in on, it differs with brand of drive, is when they're talking about over temps or under temps. Some drives most drives have the ability to do a raw calculation and figure out that they're telling you that that's the motor temp. Like, over temp's the most common one, but I'll get back to your question shortly. Usually when you get an over temp, you have to differentiate, okay, is it telling you you have a motor over temp, or is it the drive over temp? On an under temp, if it's cold, it definitely could give you an under temp fault. And in your specifications of the drive, it'll tell you when that trips in. It doesn't mean there's a problem or will quit running. It just basically is lower than most VFDs. If you look in their printed data, it's somewhere between 0 and -10 Fahrenheit is where they like to keep them there or above. So it's different for different models and different sizes, but generally that's where it is. So I'm guessing from what you've explained, if it was outside and if it was really cold, it was probably confirming that the internal temp was under the window or whatever. Basically, there's a computer inside, and it looks at all these parameters and gives you that fault and says what it is. So, hope that helps you, but. Yes, sir?
On a line shaft turbine, how quickly do you recommend getting that up to speed, from stop to full go?
Depends what brand motor you have.
Repeat the question.
His question was, on a line shaft turbine, what is the ramp-up speed recommended? Right?
Yeah.
Okay. Some of your motors, if you have a VFD, you'll start up the motor and you hear the clickety, clickety, clickety for a while. What I do, and most drives have this capability, because first of all, when it's doing the old clickety, clickety, it's wearing out that ratchet. And when you used to have the old system where you just, boom, hit the power across the line, you didn't hear any of that rattle and banging going on. For those of you who haven't heard it, it's like putting 6 steel balls in a can and going like that. It's noisy. In these VFDs, one of the good things about a VFD is you can start it up slow and you can bleed off the air and you can reduce the line hammer, right? Nice thing, doesn't beat up the check valve, it's easy on the equipment, but the problem he brought up is sometimes a problem. Some of the GE motors and some of the other motors have a quick release where you don't have near that problem, so that's why it's usually brand specific. Most of them, like on a US motor, which is probably the most common one out there, they got the big heavy steel balls in there and they'll rattle around for a while. So what I do in my drives is I program what's called a dual acceleration feature in it. So what I do is I tell the logic, okay, when you energize me, I want to go from 0 to maybe 20 or 30 hertz. That's enough G-force where them balls will fly out right away, just like the old time. And then after that, take as long as you want to start up. Now, if you don't have that feature, but most of them do. I say that, I believe most of the Allen Bradley PowerFlexes, you can put it on it, but it doesn't come from the factory. ABB, Danfoss, Yaskawa, that's standard built in. There's some other that are built in, some you have to add that to it. But if you have a single speed setup, let's assume worst case scenario, you have a single speed setup and you can't do the dual acceleration, Then it comes down to is you gotta go look from 0 to 60, because I would assume in your case, you're going 0 and then you're ramping up to full speed. You never stop in the middle someplace, right?
No.
Okay.
But my concern was, I guess I was told that you need to get water into a certain part of a bearing, a load bearing or a
Okay,
cross bearing or
that's
something.
on a submersible. On a submersible, they have what's called a shoe bearing. You have to get, if it's a Franklin, Hitachi, or any of the 3,600 RPM motors, you have to go from 0 to a minimum of 30 hertz if it's a 3,600 RPM motor, and 0 to 42 hertz if it's an 1,800 RPM, what they call a 4-pole motor. Reason being is, during the time it's speeding up, that bearing is dragging, and depends on how old you are. If you ever had chemistry class with the old chemistry teacher, and you took under the microscope and you had 2 little sheets of glass, and you put the 1 drop of water on there, and you try pulling them 2 pieces of glass apart, and you really can't pull them apart, you gotta slide them apart. Well, what happens is that bearing works the same way. It's basically working on a hydroplane. So what happens is, during the time it gets from 0 to about half speed, there's no lubrication. The bearing just grinding graphite on stainless steel washer down there, and it's just grinding basically metal to metal. Once the speed gets high enough, it brings up water film in there and it starts basically floating on water. So there's where the motor manufacturer, if they find out you're starting it without dual acceleration, they'll probably deny the warranty if it ever fails, because that's one of the biggest failures out there, is not having the dual acceleration in place on a submersible. So, yes, sir.
I think he's talking about the static, the spider bearings above the static water level.
Okay, well,
That's,
most, on a line shaft turbine, we'll go back to line shaft turbine now. If you're talking about the line shaft turbine where you got spider bearings every 10 feet, it always was industry standard to have rubber bearings, and you should have a preluber in there. Now, the problem you can run into is if you take too long to start up and speed up your turbine, you might overheat your bearings before the water column actually rises that high. We usually use about a 15-second startup to answer back on the turbine side of the question. About 15 seconds usually gets you up there. Depending on the distance to water and these things, usually that'll slow you down enough where it'll take the water hammer out and so forth. Now, there's a new product out there. It's been around in the marine business for 20, 30 years, but they've come out with what's called with a Vesconite bearing. It looks like a white Teflon looking material, and it doesn't even require pre-lube any longer. Because I know a lot of line shaft turbine pumps, you go to the pump house and you got the time delay because it needs to pre-lube for 5 minutes or whatever the case might be. But if you ever upgrade, you can put Vesconite bearings in there, then it doesn't matter. You can take all the time you want. So it takes one more issue off the table that was always a problem. So there's a product out there to solve that problem. Okay? Anything else, or I'm going to move on to the well part then. What is well efficiency? A, as it relates to the pump, and then of course B, as it relates to the well. Basically, the well is the heart of your water system, and it should be in good physical shape. Well efficiency are usually neglected or just misunderstood, and lack of proper maintenance will obviously always cost you money. I just did a quick mock-up here to kind of put dollars and cents and tie it to what efficiency might mean to you, and you'll have to kind of equate it to your world, because everybody's different. I basically just said, okay, if we figure some constants, 50 pounds of line pressure, and it can be any number, doesn't matter, and we had a pump unit that was pumping 1,000 gallons a minute, and if the one on the left here was basically at 75%, we have basically 4% deduct before wire and water loss, so basically it's 72 brake horsepower, so basically it's 2.9 brake horsepower savings. And I should back up here. Basically what I'm doing is doing a side comparison. 2 identical wells, one's at 78%, one's at 82%. So I took the disparity between 78 and 82, that's where my 4% comes in, and said, I got 2 identical wells, they're twins, everything's the same. The only thing I changed is this one has a 78% efficient pump in, this one has an 82% efficient pump. I amortized it out, ran it out, and basically if you had that disparity and if you were paying 10 cents a kilowatt, it'd be about $324 per well per year. If you had 4 wells, it's about a $1,200 savings. That's just in pump efficiency. So when it comes time to replace a pump, that's a question you should be asking and saying, how efficient is that pump? It's usually we won't sell any pumps that are less than 80%, and it depends on smaller pumps, like if you get down into the 1, 2, 350 gallon a minute sometimes they're hard to get little pumps up above the 80% benchmark, but usually when you get into the mid-range, like 300, 400 and up, 80 to 84 is pretty much the industry premium pumps. So that's just looking at two identical pumps, everything working right, just how much more savings can I get with just 4% efficiency. The next, and here's what a curve might look like. Here, if you look at the, where my little guy go, okay. Every pump curve should have what's an established efficiency. This particular manufacturer is showing there's 80% right there, so it's run out at 80%. So if you operate that pump at 800 gallons a minute, that's going to generate 82% hydraulic efficiency. Same pump company, just a different model. Basically same thing here. It only gets up to 78%. And there again, that's a 300 gallon a minute model, which like I mentioned, it's pretty common, smaller gallons, lower efficiency. Okay, then I moved on and said, okay, well, probably a bigger issue I see out in the field is wells that are just wells are inefficient. The pump is just fine. So how much would it cost to keep pumping a well that's in need of rehab, and what's the real cost, not even factoring pump wear and tear? And so I did the same thing, took the same pump and said, okay, if I have the same 50 pounds of discharge, same static water level, and this well pumps at a pumping level of 200 feet versus this well at 100 feet, everything else being a constant, took a 1,000 gallon a minute pump, it computes out to be a 35 extra horsepower to lift that water, that extra 100 feet, at 10 cents a kilowatt, amortized it out at 1,200 hours of operation a year, times 4 wells, that's $12,000 plus a year, just in electrical cost alone, if you have an inefficient well and are lifting water an extra 100 feet. So that's where the well efficiency comes into the picture. So usually well inefficiency becomes a bigger payback or potential payback keeping the well in service than the pump. Because usually the pump either runs or it doesn't, and you can do a raw calculation and figure that out pretty quickly. Sometimes there's nothing you can do about the well efficiency. And here, this slide I got from Johnson's screen, they're basically comparing a wire wrap screen to a slotted screen. If they use bad materials when they built the well, you're going to have more drawdown because the screen has less open area. There might not be too much you can do about it because that's the way they built the well. So what their claim to fame is put the most efficient screen you can in because you're going to lower your pumping costs. Of course, you're going to have less run hours, you're going to have less pump wear, longer well life, and easier rehabilitation on the well if you have more open area. Okay, knowing your well specifics is kind of like knowing your blood pressure. I'm pretty much sure everybody in this room has different blood pressures, days of the week, whatever, but what's normal? Every well's different. You can't, even the same well field in the same city, a couple blocks away, wells will have different specific capacities, so you can't. I mean, some people, what's a really good well? Based on what? Compared to what? Each well is, you need to start with a baseline. So usually what I'll do is take and try and find data on the well when the well was new and drilled and find out what that well's specific capacity was, because that's my benchmark. So if I find out what my benchmark is and find out what my specific capacity is, I mean, one person's well, if it does 5 gallons, it's kind of an analogy like miles to the gallon on a car, except for here I'm doing gallons to the foot. There's a number system, we can come up with that pretty easy, but basically what ends up happening is one well might have a specific capacity of 5 gallons per minute per foot, one might be 40. Two unique individuals. Yeah, the one with 5 might cost you more to pump water, but that might be what the regional geology delivers, and there's nothing you can do about it. It is what it is. So every well is different, and what we want to do is establish what the new benchmark is on that, and once we know what that number is, then we know when the well should be cleaned. AWWA says when your yield falls off by 10%, you should be looking at rehabbing, because if you don't, each time you have the water specific capacity go down to a certain level, we rehab it, you usually don't get it right back to new. So it's like a ratchet effect. You go up, down, up, down, up, down, and eventually over time, maybe 50 years, maybe 60 years, depending on the well and the water quality, pretty soon the well's going to become obsolete and it's not going to be able to be recovered. Here's just a picture of 2 different types of screens. The one on the right is the high open area. It makes it much easier to jet through the screen because we're trying to clean out the material behind the screen, so I won't spend a lot of time on that. It's pretty straightforward. It's a mechanical process. If you just got slots in there, It's going to be very difficult to clean, and you're comparing about 2% open area to about 25% open area. So if you get into water dynamics, anytime water moves faster, it starts dropping out its baggage and starts getting mineral and crustacean and whatever. If you talk to engineers, we get concerned about how fast we're pushing water down the pipeline. Well, in the well, we're worried about how fast the water passes through the screen because it leaves more mineral and crustacean behind it and it plugs up much, much quicker. What causes the reduced yield? Well, even in a brand new well, if you got drilling damage, you're drilling down through the formation. You can't see it from the back of the room, I'm sure, but the picture basically shows if you're drilling with mud, you're always going to have some mud loss. You're cutting. Most sand formations are like platelets. I guess if you think about it, when water, glacier, and flow came by, if you get a good geologist, they'll look at the bottom of the creek and they'll look at it and you can see where most of the rocks are going to go with gravity. If it's flat like a plate, it's going to fall down, right? It's going to be horizontal. Well, what happens basically is you drill through it, you break some up, you break some off, you tip some sideways, that all creates blockage. So in the development process, after you're done drilling the well, you're trying to restore that to get everything lined up. Our drillers refer to as particle realignment. So they're trying to get everything laying horizontal because the water will travel 10 to 15 times easier horizontally through the gravel formation than vertically if it was laid down with basically water. Other things that can cause reduced yield are, of course, corrosion buildup, just fill silts in the bottom of the well, bacteria, biological action, iron fouling, silts, fine sand coming in against the screen, or just the natural aging processes. I've been doing videos of my own for a long time, and it's interesting, especially on deeper wells. I look at a well, every well has its own environment down there. It's hard to think about environment, but then when you start drilling and all of a sudden you get down 200 or 300 feet and you start pulling out chunks of wood and pieces of coal, it's like, you know, there was an environment down there at one point in time, and here there might, I don't know if that squirrel that was living back then under the tree when the glacier was coming, I don't know if he's still down there or not, but then over there he might not be. You know, so you got to think about it. There's a lot of things going on downstairs that we probably don't think about or we take for granted. But when I video a well, I will actually, on deeper wells, be able to identify some of these zones because where the water goes up and down, and those of you that may have a little bit of background in wastewater, you've got your aerobic zone because it's wet and or dry. If you've ever been down to the dock, down by the ocean side or someplace, you look at the pole that's sticking into the water, where do you see all the buildup? Right at that water line where it's getting wet and dry, wet and dry. That's where the fence post rots off. That's, you got different climate there. You get down deeper, there's where you're usually going to find your slime forming iron bacteria. Get down to the bottom, you're going to have sulfur reducing bacteria. And I'll show it in a later photo here where I actually have some actual footage on there, but a lot of times you're going to have 2 feet, 10 feet, 20 feet, 50 feet of accumulated rust sludge and stuff on the bottom. Well, that's going to turn anaerobic real quick. You virtually have a septic tank down there, and some people complain, well, how come I'm getting stinky water after the well's 10 or 15 years old? That might be part of the reason, because you got a dead zone down there. But nowadays with the color cameras and good resolution, you go down the casing, a lot of times you can pick out these different environments on the way down to the bottom of the well. Usually, if you got a 200 or 300 foot deep well or deeper, you can really pick them out. Shallower wells, not so much. Why do wells plug up? I guess a lot of people ask me, well, geez, you know, that groundwater's been sitting under the water in the gravel down there for years. How come it's not rusty? How come it's not this? How come it's not that? Well, what happens is you start pumping, and the faster the speed, you start bringing all the nutrients, calcium, iron, manganese, you start bringing them into the well environment. And if there's any resident bacteria, now they may not be harmful bacteria, but I can pretty much assure you that most wells have some sort of biological activity down there of some sort, whether it's sulfur-reducing bacteria, iron bacteria, there's going to be something, some sort of a living organism down there. And basically you just put on a smorgasbord, you just brought all the food to them. They don't have to go very far, they're not going to swim very far, they're just going to sit there and eat and be happy. And of course build crustacean and slime, and then cause you problems. Here's a side view of a grossly exaggerated screen. So if this would be your screen, it's usually built out of triangle wire. And sometimes we'll run a video and the inside of the well screen looks pretty clean. And it's like, well, why did our yield drop off to 50% or whatever? Well, what you have happen is out behind the screen, these surfaces of each little sand pebble, if you look at a grain of sand under a microscope, it's going to be rough. Bacteria can attach themselves onto it real easily, and pretty soon they fill the spaces between the gravel. and start oxidizing, and then pretty soon you have all that buildup out here. And I've pulled out screens and wells that are so hard you have to physically take a hammer and pound it off. It looks like cement block material coming off of there. I don't know, I think I hit the wrong thing there. Where's my, wrong button, sorry, apologize for that. There we are, thank you. There's a company in Germany, those of you who followed frac sand or whatever, there's a company in Germany who's playing around with making glass beads to put between the well screen and the native formation. So out here would be the native formation. The nice part about glass is bacteria, because of its smoothness, has a very difficult time hanging onto and attaching itself to glass beads. It's expensive. I've seen a couple studies done in Arizona. It has some merit. Now, when will that become something we do up here? I'm not sure. This is just a under the microscope vision of the bacteria. Here, I'm told to hurry up, so I'm going to kind of rush here. This is a BART test. If we're thinking you got iron bacteria, we'll run a BART test. You can identify whether you do. This is biofilm in a let's see here. Biofilm in a well. That just looks like hairy stuff hanging there. That's all slimy bacteria. One other thing I want to show you. I think this is important. I'd like to get. For years, you almost have to identify what the problem is before you come up with a fix. We started using a product called WaterSafe, and the first time the guy basically started telling me about it, I pretty much hung up on him because I told him nothing could be that good. Interestingly enough, if you work with muriatic acid, of course you got to have gloves on and goggles and all that stuff. This stuff here, you can put your hands in it. You can actually get it in your eyes. You don't have to. It's environmentally safe. It has a pH of, what they did is they took a 1-inch calcium carbonate cube and dissolved it, and this is the different acids and how much carbonate it removes. So it actually removes calcium carbonate faster than muriatic acid. And I'm thinking from the old school. Let's see, it can dissolve carbonate, but I can put my hands in it, and it's not going to hurt me. I'm just not buying that. But anyway, it actually works. Basically, we use it to replace hydrochloric, hydrofluoric, ureas, sulfuric, all the different types of phosphorus. A pretty common one for well cleaning. It's a very easy acid to work with. It's environmentally safe. It has 0, 0, and 0 on the hazard scale if you're into the hazardous stuff. So basically, you don't have to placard your truck. It doesn't eat steel. There's a picture of a screen that's properly cleaned, side view. That'd be an open hole. There's my camera. I just had that one's actually down in Minneapolis well. And this one here I was going to show, I think this one here is, I got to click on that screen there with the mouse, just right in the middle, just click there. I want to show how much organic buildup you can have in a well. It might take a little bit. If you just click on it, double click, it should go. It did before when I was at that mouse. Okay. Well, basically, we have a special piece of equipment here that we can go down and put it inside of a pump house if you need to. What I was going to show you on that last film that didn't want to come in there is I actually videoed a well. There was so much organic growth in it that I put the camera down and I have a side view lens and I put it right at the thermocline. And within about 10 minutes, I had 3 inches of vertical buildup just from what I knocked off the walls filling up. And that well had actually 40 feet of organic material in that well. So I don't know what will be in that bottom 40 feet, but I'm sure it'll be pretty nasty. So sorry we're out of time. I actually had this normally for a longer presentation, tried squeezing it in there. So if you got any questions, I guess give me a call or whatever.
Yep, let's just cut her short. If you have questions, catch Dave in the back of the room here, but let's give him a round of applause. He did a good job.